Calorimetry is the study of measuring an energy transfer, or heat, by observing temperature changes. These measurements occur in a calorimeter like those seen here. A calorimeter is a heat insulator like styrofoam in a metal alloy can, or can be as simple as styrofoam cups in a beaker. Ideally, we would select a calorimeter that absorbs minimal heat. In calorimetry, we want to measure the change in energy of a system. Recall, internal energy is work, W, plus heat, symbolized by the letter Q. But in calorimetry, we are focusing only on the heat. No work is being done in the process. Thus, delta E is heat. Every substance has a heat capacity. The heat capacity is the energy required to raise the temperature of a substance by 1 degree. The specific heat capacity is per gram, and the molar heat capacity is per mole of a substance. For example, heat is equal to the mass of the substance studied times the specific heat capacity of the substance, denoted by the letter S here, times the change in temperature caused by the transfer of energy or heat. Let's take a look at an example. Find the energy in joules and kilojoules to raise the temperature of 85.0 milliliters of water from 25.0 Celsius to 47.0 Celsius. The specific heat of water is 4.18 joules per gram per degree Celsius, and assume the density of water is 1.00 grams per milliliter. Here's our equation. The energy required for this process to happen is the mass times the specific heat times the change in temperature. In this example, we have a sample of water. It's 85.0 milliliters. If we're assuming 1 gram per milliliter density, we can just put in here 85.0 grams of water, and we'll multiply by the specific heat. Recall specific heat is the energy, 4.18 joules, required to raise the temperature of 1 gram of water by 1 degree Celsius. So that's what the units mean here. And the change in temperature, the water initially is 25.0 Celsius, and the final temperature, 47.0 Celsius. And so the change in temperature here, when we're subtracting numbers, we'll go with the fewest decimal places. Here we'll report 1 decimal place. So this change in temperature is 22.0 Celsius. If you look at the units, those Celsius cancel, the grams cancel, and so we're going to multiply these terms. When we multiply these terms to 3 significant figures, we get 7,820 joules, or if we convert this to kilojoules, 7.82 kilojoules. So this means this is the amount of energy required to raise the temperature of 85 grams of water from 25 Celsius to 47.0 Celsius. Here is one example of using the molar heat capacity. Copper has a molar heat capacity of 24.5 joules per mole per degree Celsius. Find the heat when a 50.0 gram sample of copper experiences a temperature increase from 23.0 degrees Celsius to 32.4 degrees Celsius. In this example, we're looking at the molar heat capacity of copper, And we have a 50-gram sample. Now it's up to you if you want to convert the grams to moles and use the molar heat capacity. I'm using this equation, the mass times specific heat times the change in temperature. So for me, what I'll do is I'll change that molar heat capacity, 24.5 joules per mole of copper per degree Celsius. And pretty simple conversion here. I'll convert the moles into grams of copper and cancel the mole of copper, put that in the numerator. And this, of course, is just the molar mass of copper, 63.55. You see those moles cancel. And so right here, I've converted to the specific heat rather than the molar heat. But you could have used the molar heat capacity and used the number of moles of copper. You could have done that as well. So there's my specific heat capacity. Now I can just plug and chug into the equation. So I have a 50-gram sample of the copper. My specific heat capacity is 0.386, and my change in temperature is 32.4 degrees Celsius minus 23 degrees Celsius. This change in temperature right here is a 9.4 degrees Celsius. And so when we plug all this in to 2 sig figs, because of the 9.4, 2 significant figures gets me 180 joules. You can always convert this to kilojoules. This is 0.180 kilojoules.